Welcome back. Today we're going to be solving some more inequalities. So I'm assuming you're doing all these in order. If you're not, definitely make sure to watch the previous classwork video and work through those problems before this one. So what we did in the last classwork was we solved inequalities, and we did it using a very specific process that was outlined in the book. I know a lot of you will be tempted to just pretend this is an equal sign, solve, but that's not always going to work. So don't do it that way, at least not yet. So here's what we're going to do. I'm going to show you an example, and then you can use the example to help you with 56, A, B, C, D, E, and F. So step one, we want to know where the boundary is. So once we know where the boundary is, then we just need to find which side all the solutions are on. So let's set these equal to each other. 10 minus 4/3 x equals 26. And then we want to solve for x. So subtract 10, we get negative 4/3 x equals 16. Remember that to get rid of a fraction, you can just divide by it or multiply by its reciprocal. So I'm going to multiply by negative 3/4 on both sides to get x is equal to negative 12. So step 2, we're going to plot the boundary point. I'm actually going to do it down here, so I only have to draw one number line. So let's say this is 0, negative 12, negative 24. I like to just scale by whatever number I get, right? Your number line can be however you want it to be as long as it goes up or down at a constant rate. So we're going to plot the point, and we are going to use an open dot because negative 12 should not be part of the solution. So if negative 12 is the value that makes these two sides equal, but there isn't an or equal to sign, then we know that negative 12 is not a solution, so it shouldn't be shaded. But it's still an important point, so we're going to use an open circle to say, hey, look, the solutions have a boundary at negative 12, but negative 12 isn't part of the solution. Step 3, we want to test a value that's not the boundary point. Okay, we want to choose a side. Like we know one side has the solutions and the other doesn't, so we just need to test a point and figure it out. So I always like to test 0, because 0 makes all the x's go away. So let's do that. So step 3, we're going to choose x equals 0, just because it's nice. I could have chosen any number I wanted except negative 12. And we plug it in, so 10 minus 4/3 times 0 is greater than 26, but times 0 is just nothing, so 10 is greater than 26. That is a very false statement. 10 is not bigger than 26. So if it's false, we just found out that 0 is not a solution, which means that everything on the 0 side is not a solution, which means that the solutions must live over here on the other side of negative 12. And in step 5, we want to just write it as it was originally, except with x by itself. So we can see that x must be less than negative 12. And that would be our final solution, along with it graphed on a number line. I know normally when you think of graphing, you think of the xy plane. This is actually just graphing in one dimension. So when we ask you to graph it on a number line, you don't need the other axis. It's just a number line, shade in the parts, the numbers that make the value, or that make the inequality true. And that's all. So I'd like you to try it now. Try it for A, B, and C, and then we'll check in, make sure you're on the right track, and then we'll go over D, E, and F. So A, B, C, go for it. Welcome back. For parts A, B, and C of 9-56, here is what you should have gotten. Notice there's an open circle for parts A and C, and a closed circle for part B. Also notice that if you were doing it the way that I didn't recommend, so just pretending it was an equation and then just solving and keeping whichever way the sign is going, then you would have gotten the wrong answer. You do need to test a point to make sure that you've gotten the right inequality. I'll talk about it in the next video. It does have to do with multiplying or dividing by a negative number. It changes the way that the inequality goes. So I'll talk about that more next time, but for now, please just use the method we've been talking about. It builds a deeper understanding of inequalities. Okay, so now that you've checked your answers, you can do 956 D, E, and F, and I'll be back to check the answers. Okay, so here is D, E, and F. D was pretty straightforward. The parts E and F, though, were super weird because, like in part E, when you set them equal to each other, you get 9k minus 3 equals 9k minus 3, or just 0 equals 0, or negative 3 equals negative 3. However you wrote it, it's a true statement, and it's always true, which means that you can still test a point, except this time, instead of telling you which side of a boundary it's on, it's going to tell you whether it's all real numbers or no solution. So like if you can test any point, you can plug in like 10 or whatever, and you will get that it is a true statement. The two sides are equal, and so that means that any real number is going to work. Whereas in the second case, you also get something like 0 equals 0, or 1 equals 1, whatever it was. But if you test a point, it's not true. So that means that there is no solution. That's all for 9-56. Let's move on to 9-57. So 9-57 is a word problem. I know it's your favorite, but I promise this one isn't too bad. You will need to write a let statement. So remember that when you write a variable, like let t equal the number of hours or whatever, you will be doing that in this problem. You'll be setting up an equation and solving. So take a look and we'll go over it in a moment. All right, let's look at 957. So the information that they give us is about the number of Turks and the number of Kurds. They do tell us that the total number of both of them is 66 million. So that means that when you add together the number of Turks and the number of Kurds, so T plus K, you should get 66 million, or as I think when I'm writing it, 66 and 6 zeros. They also tell you that the number of Turks is 4 times the number of Kurds. And so that means that you can kind of just put it in math, translate. So the number of Turks is 4 times the number of Kurds. That's it. And now we have to solve. So what we can do is some substitution, right? So if we know that T is the same as 4K, let's put that in for our T here. So we end up with 4K plus K equals 66 million. So 5K equals 66 million. Oh, so many zeros. And that means that we get K is equal to 13,200,000. So from there, if that's the number of Kurds, we can also figure out the number of Turks, which is just 4 times that amount. So we get T is equal to 4K. So just multiply this number by 4 to get 52,800,000. And those are our solutions. Okay, so now we're going to look at another word problem, but it's the last problem, so bear with me. 9-58, A and B, is one of those problems that, similar to what we looked at when we did chapter 4, systems of equations, where you have a situation and you have a starting value and then you have a rate of growth. So just try to remember how that relates to y equals mx plus b, and that should help you with 9-58 A and B, and then we'll go over them. Welcome back. Let's look at 58A and B. 58A, you can write it however you'd like, but an inequality is what we need to use because it's not just one solution that's going to, there's not just like one number of years. Like you have to send all of the trees at this number of years. You just need a minimum, and then any value after that would work as well. So that's like an inequality. Like not just one point on a number line, but a whole region. So if X is the number of years since planting, they tell us that the sapta plants start at 6 centimeters. It's like our initial value. And grow 9 centimeters each year. So that's like adding 9x, right? If we were to write an equation, y equals mx plus b, we could say that the height y is equal to 9 times x plus 6. We need that to be greater than 150, right? Because once it's 150 centimeters tall, that's when it starts flowering, and we want it to flower because then it's pretty and then it makes a nice gift. So we need to solve this, so let's set it equal. 6 plus 9x equals 150, 9x equals 144, and x equals 16 years. And we know that time is like moving forward, the tree goes up, time goes up, right? So if you really want to, you can test a point, but just thinking about it, we know that it's going to need to be greater than 16 years. Similarly, we can think about what we need for part C. So we'll set up another inequality and solve. And I challenge you to write your final answer as a compound inequality where x is in the middle and then you have like the whatever's on the outside, the bounds. So 58C, we'll go over it and then we're done. All right, in part C, we had another inequality, but this time we needed it to be at most 240 centimeters. So the values that it will work will be less than or equal to 240. Let's solve for x. So 6 plus 9x equals 240. 9x equals 234. X is equal to 26 after we divide by 9 on both sides. So we do know that, again, so since we need to be less than 240, in this case, since time is moving forward, we want it to be under 26 years old. And so if we want to be less than or equal to 26, but also greater than 16, this is how we can write a compound inequality is what we call it, to represent the situation. All done. Have a great rest of your day.